Okay, so we're going to have a look at this parallel circuit. We've got three resistors, R1, R2 and R3. And we're told that R1 is equal to R2 and is also equal to R3. So these three resistors are identical to each other. So the first thing we're going to do is have a look at these two currents here, I1 and I2. So this current of 0.12 amps flows through the battery, comes down here, and then it splits in two along here. And you've got obviously twice the resistance in this top section of the circuit compared to the bottom section of the circuit. So we're going to try and do this using an algebraic method. So we're just going to say that I1 is equal to whatever the voltage is across this section, V, divided by 2R, because there's two of the resistors there. And then I2 has got the same voltage across the section, across the branch there, but it's going to be divided by only one resistor, R. So if we look at the ratio of I1 to I2 or I2 to I1, it doesn't matter. We can just divide these by each other. It's probably easiest to divide I2 by I1. So we're going to get V over R divided by V over 2R. And then that is equal to V over R multiplied by 2R over V. Because whenever we divide one fraction by another, we just flip the bottom fraction, the denominator fraction, and multiply the two fractions together. So simplifying that, they're going to cancel out, they're going to cancel out. So we know that I2 over I1 is equal to 2. So that's essentially to tell us that I2 is equal to 2 times I1. I2 is twice the current through I1, and that makes sense because I2, this branch here has half the resistance of this branch, so you'd expect twice the current to go through this branch when compared to this branch. Now, we also know that the total current I, if we call this I, we know that that's equal to I1 plus I2. And if we replace I2 with 2 times I1, this here, we can rewrite this equation as I equals I1 plus 2I1. And that tells us then that I is equal to 3I1. So I1 is equal to I over 3, which is equal to 0.12 over 3, which is equal to 0.04 amps. Okay, and since that we know that I2 is twice I1, that I2 is twice this, which is just equal to 0.08 amps. Okay, so that's part A done. Now we look at part B. Now with part B, we're looking for the potential difference across this resistor and across this resistor. Now we know that each branch, each section of a parallel circuit has the same voltage across it, has the full battery voltage across it. So the potential difference across R3, so PD across R3 is just going to be equal to the full battery voltage, which is 9.6 volts. The PD across R1 is just going to be equal to, well, these two resistors, that full branch there has 9.6 volts across it, but there are two resistors in that branch in series, so the potential difference is going to be shared between them, and since they've got the same resistance, it's going to be shared equally, so the potential difference across R1 is just going to be 4.8 volts. It's going to be half of the 9.6 volts that is across both of these resistors here. Okay, now if we look at part C then, the resistance of R2, now to work that out, we're going to use the equation R equals V over I. We know that the voltage across R2 here is going to be the same as the voltage across R1. Okay, so I suppose that should be R2. We know that there's going to be 4.8 volts across here, so 4.8 volts, and we know that the current through this section is I1, which is 0.04. Okay. And we know if we do 4.8 divided by 0.04, that is going to equal 120 ohms. Okay, so now we've got the resistance of R2. Now finally, we're going to work out the total resistance. Now to work out the total resistance, we've got two resistors in series. So we're just going to add their resistances together. So the resistance of this section is just going to be 120 plus 120, because remember each of these resistors is identical. So that's going to give us 240 ohms. So this section is 240 ohms. This is 120. So you could say that this is 240. This is 120. These are in parallel. So we're going to have to add those up using the parallel circuit equation. 1 over RT is equal to 1 over 240, because that's the total of that section, plus 1 over 120. Okay. Now, 1 over 120 is equal to 2 over 240. So that's going to be, can be written like that, which gives us 3 over 240. And then to get RT, we just need to flip this side to get RT over 1, and then flip that side to get 240 over 3. So RT comes out as 240 divided by 3, which gives us 80 ohms. Okay. Now there is an alternative way of doing this bit as well. And in fact, it's easier. So the alternative way of doing this bit is just to say that the total circuit resistance is equal to the voltage of the circuit divided by the current, and that is equal to that's going to be equal to 9.6 divided by 0.12, which would equal 80 ohms. So exactly the same result, just a different method. There we go.